Hi everyone, Zach here, and welcome to lesson 58 in this series on developing a survival game. In this video, we'll be setting up our lightning material and our lightning emitter. This video and this series have been brought to you by Patreon sponsors. And you too can help this channel out. All you have to do is hit that like button down below. And if you want to take your support a bit further, well then hit the subscribe and notify bell. And if you want to go even further than that, consider becoming a Patreon sponsor. Patreon sponsors get early access to these videos. Alright, open up your projects and we'll make a start. Hi everyone, and welcome back to the editor. I'm still really annoyed about the grass thing, by the way. You still can't convince me that 2.3 isn't the best version of the engine. That aside, what we're going to do in this video is create parts of our lightning system. Now, it won't be fully implemented until we get later into this section. Now, the first thing we're going to do is we are going to take some materials that I've created, textures that I've created, and bring them into our project. So if you open up the asset pack for the series, go to weather, there should be Sparks 01 and Sparks 06. In fact, I made 8 different things, but that's for a different project. We're going to go to textures. We are going to create a new folder in textures called weather system, or systems plural. Pop that open and grab your sparks and drop them in there. Now I'm just going to Control S, save everything. We're going to open them up in just a moment, and we are going to get rid of the sRGB. And you can see that it's just a simple gradient system, moving from brighter in the center to to lighter as we move out. So it's fading away. We're going to use the alpha to lerp between the brightness of our material. Similarly, we have just an alternate version with 0.6 where we have a little bit more of a starburst pattern, and you can pick between which ones you want to use. All right, now technically, I mentioned using material instances in the last video, or 2 videos ago. We really should have done that for the rain system, and you can go back and update it if you want. We will definitely be using material instances for our lightning materials. So if we go to materials, in our weather system, we're going to create a new folder called lightning. Pop that open, and in here we're gonna have 2 materials. So we'll start with our lightning itself, and that's m_lightning. I feel like I have the T in the wrong spot there, because I did. As you can tell, I still have all the Niagara stuff open. Sorry about that. All right, let's just pop this open, move that there, and this is going to be, well, not one of our base materials. It's going to be surface, but it's going to be an additive material. It's going to be unlit. It's actually going to light itself. It will be 2-sided. We will not do any shadowing from this. And in this case, we are going to need to set it up to work with a Niagara system, but not a sprite system. Instead, we need to work with the ribbon. So it's Niagara. Can't read it. You can, well, not click there, but scroll out like that, or just highlight like I do. So use with Niagara ribbon. All right, and I believe that is all the settings we need for this one. I'm just double checking my prep file. It is. All right, so we're gonna work a bit backwards with this. We're gonna start with over here and then work to the stuff that actually makes it lightning. First we're gonna use is a node called black body, and that just sort of helps us, well, mask out the parts we're not using in our material. So if you pull off emissive and search for black, you find black body. Pop this open because we're gonna use this as a preview. We are next going to do a lerp. So we're going to do a linear interpolation between a value of 0 and a value that will, we're going to create a dummy value real quick, and we're going to create the real value as well. So I'm going to just right click the B, this is a dummy one by the way, and promote to parameter called temperature. Now, what I want you to do is find the value when we finish this out that you like for your system. And I'm going to default this to a value of 8,000. Yeah, that is a large number. Now we have a big glowing ball, kind of what we're looking for right now. I'm gonna set the base min to, because I've tested this out, to about 5,000. In fact, actually I would never go below 8. And I'm gonna set the slider max for this to 12,000. All right, next what I'm gonna do is I am going to create the real parameter that we're gonna use for this system. I'm not gonna plug this in until we actually get to that part of the system. And that is a dynamic parameter under particles here. And I'm going to select it. I'm going to rename the first parameter from param1 to temperature. And I am going to put whatever value I decide from this node when I test it into my temperature, which will be 8,000, by the way. All right, but play around with it before you plug that in place of B. What we need to do is then make this into, well, a lightning bolt. And hey, would you know it? There's a node for that. So I'm gonna pull off the alpha and I'm gonna type in generated band. All right, now what you might notice is we've lost the top. And if you look at our black body, we have this cool little ring effect. In fact, we have a nice little circle light there. So hey, if you ever wanna make a circle light, there's your circle light. All right, I'm gonna put a reroute here, line that up, and that's going directly into opacity, just so I can more easily see what's going on. So we're using this for our opacity and for our light, where we're gonna have the emissive color, because we don't want the entire thing being emissive. This black body is what's masking it out. And notice that we have that nice little fade on the edges from the black body as well. Now we can change the size of this with our width and our sharpness. So we're gonna start with our width, and we're gonna do a parameter here. And I'm actually thinking might be a better way using the second parameter value, but we'll talk about that down the road. For this, we're going to set the width to a default of 0.02. And notice now we have this nice tight little ring band thing going on. If we go to 1, we get the full sort of circle back. We go to 0.5, we get half a circle. The tops and bottoms are cut off. It's not really half a circle, I realize. 0.25 should be half the circle. There we go. That's the default. Remember, it's removing from top and bottom. So it's 25% on each, really. If we go down to 0.01, we have this very narrow band. If we go back to, say, 0.1, we get a much thicker band. So you can play again with the settings until you find a value you like. My default value will be 0.02. And again, for dynamic weather systems, we might really want to use this dynamic parameter. We need to take care of our sharpness as well, so we're going to promote this to a parameter called sharpness. Could have just deleted the parenthesis s. And let's set this to a value of 0.1. And notice it's really subtle. Let's set this back to 1 for a moment. You can see how that affects the lighting, the sharpness of that lighting. So I'm gonna just go back to say 0.5 for a second. Notice how it affects the sharpness on the edges. Let me just zoom in a bit more. It's a little bit clearer up close what I mean by the lighting here. Let's go to 2 again. You can see that the sharpness on those edges, the lighting of it's changed a bit. Go back to 0.1, so we get a little bit less warmth off of it. I actually might want to lower this to 0.01. No, I lied. I don't want to. We're going to leave it at 0.1 for now. Now, one thing that you might want to do if you weren't using a Niagara system is you might want to switch the bool. And for the purposes of setting this up, we actually are going to do that. We are going to promote this parameter. We are never going to use this parameter in any way outside of just the setup here. I'm going to mark this as true by default. And now notice we have an upright band. This again is just for testing purposes. We will be setting this back to false in just a moment. So next what we need to do is we need to create some noise and use that noise to move our band. And that is our import coordinates right there. So what we're going to do is now we're going to go over this way and we're going to do a panner node just like we normally do for moving something around. And in this panner node, we're going to set the default value to negative 0.5 by negative 0.1. We are then going to take this and we are going to make it a vector, we're going to append it to a vector. And we're just going to use this to help sort of balance it out. I'm going to hold the 1 key down and click, take that 0, plug it into our B there. And then I'm going to pull off of here and I'm going to search for a noise texture or a noise node. And I'm going to just move this over to the left a bit. I'm going to pop this open so we can see what the noise is. And I'm going to unplug it just for a moment so you can again see, hey, we have these dots, these little dots that are actually world aligned. You can tell when I move. I'm going to plug that back in, and now you can see we have these sort of cloudy dots. Well, we're going to change our cloud just a bit. We want the scale to be a bit bigger, so we're going to change the UV to 1.5. And notice that they now have that new shape to them. We want this to be a fast gradient 3D texture. We will want to leave the levels as is, but we're going to change the output min to negative 0.1 and our max to 0.1. And notice now that we have more spacing between them. I'm going to take these 3 nodes, not the 0, and I'm going to duplicate it. I'm going to line them up down here. In fact, I'm going to move these to line it up. And I'm going to take from the 0, plug into that B, and I'm going to go to the first panner, or the bottom panner that is, and I'm going to have this value, actually I'm going to double this value, not have it, to negative 0.25. You don't know why it's doubling. Negative moving towards 0 is increasing the number. I'm going to change the speed Y to 0, and notice now that I have slightly different movements there. I'm going to go to my noise node on the bottom here, and I'm going to change the scale to be much larger in value there, so it's a 4. And again, you can see the tiling a little bit more easily because it's much larger of a scale there. Again, fast gradient 3D. I'm going to remove the levels down to 5, and I'm going to change my min output to negative 0.08 and my output positive, or max, to 0.08 positive. So notice that the scales are just literally moving equal direction for min and max. I am going to mix these two together, so I'm going to append, and one will be my red value. So remember, append is a 2 vector, which is red and green. A vector 3 is red, green, blue. We don't need the blue value, by the way. So this is my red value, this is my blue value, and to prove that, sorry, green value, I didn't mean blue. Of course, I made that mistake right after I opened it. And I got it right earlier when I said that the third vector is blue. Wow, I am just messing things up today. All right, let's just move that down a little bit. And now what we're gonna do is we are going to add this into a texture coordinate. So we're gonna do texture chord. So we get our usual lovely little colorful band here, which we're gonna make into colorful little moving clouds. And I'm gonna do add. Look, hey, we're adding 1, so we're just getting that nice yellow color. Let's add in this instead. And we get this sort of really kind of cool, I really like this. Like, I don't know why, but I want this like as the wallpaper for my computer. So we get this nice little moving band of color going on there. All right, we're gonna take this and we're going to apply it to our input coordinates. Now, I already know the values I'm using. So what I want you to do, and I'm gonna walk you through this, is I want you to take just a plain, well, plane actually. So we're gonna search for a plane. We're just gonna drop it onto the map somewhere reasonable, like right there. And I'm going to apply this texture to it. Actually, first I'm gonna create a material instance of this texture. I'm going to save and then apply that texture. Hey, there's our lightning bolt. I'm going to rotate this so it's upright. And I'm going to scale this in the X by 200. Oh, that was the wrong one. In the Y by 200, there we go. And I might want to scale it on the X as well, actually, by say 15. There we go. So we can see the lightning bolt. I'm going to move it up just a bit. Actually, I'm going to hit end, which does not seem to be working this version of Unreal, but whatever. There's our lightning bolt, and you can see it's tiling a bit. I did make it a little too big. I can move it down to fix that issue. So let's just move it down. There we go. Hopefully that was enough to hide the tiling. Yeah, the tiling is under the ground now. What I want you to do is open up your parameter, move it to the side as we did with the water, and find the values that you want to work with. Once you have found the values you want to work with, resume this video. All right, welcome back. So hopefully you found the value you want to work with, and we're just going to delete this plane because we don't need it anymore. We're going to switch this back to false, which gives us now a ring of lightning. Don't worry about that. This is just because of how we're going to use it in our Niagara system. All right, so let's go back to our map here. Let's just Control S, save everything to be on the safe side, or Control Shift S. Let's go over to our core. Sorry if you can hear the wire scraping along the microphone. I'm tangled in wires today, it seems. And we are going to go to our particle systems. We'll go into emitters, and we're going to create we're going to create 2 new emitters, really. So the first one we're going to create is our lightning system, and this is going to be really, really hard to see how it's going to work. So just trust me as I explain stuff. And we will do new empty finish ne underscore lightning. And let's Control Shift save, pop this open. Let's go down to our sprite renderer and right click, delete that, hit render, and add in a ribbon renderer. All right, in here, of course, it's going to be our lightning. There we go. For facing mode, we will use custom. For our UV settings, it will be smooth transition on both for the leading edge and trailing. For our distribution, we will scale uniformly. Actually, let's leave it at this for now. We'll look at this later on. For our UV2, it is smooth transition. By the way, if you don't know how I know this, I think I did do this one in a ribbon originally, and then I decided I didn't like working that way. Again, scale uniformly. I believe that covers everything. Let's go up to our emitter. We do need persistent IDs for this one. I don't fully understand why, to be completely frank with you. Let's go to our emitter state. Again, this will be self. We will do once instead of infinite, and we'll set that to infinite, Then we need to do a beam emitter setup. So under our beam emitter setup, this is where things get a bit funky. We're gonna mark the beam start and end as both being absolutes. And then we are going to change this simulated position. Actually, what we're gonna do is create the variables first. We're going to click the user exposed. We're gonna do a vector, and this will be start location. And we're gonna just drag that over our simulated position to replace it. Now this is the part that means we can't actually see this in action. We're gonna give a start location in our weather system. We'll actually demo it really quickly outside of our weather system, I think. I can't remember how I've set up my recording schedule for this. We're gonna do vector again, and this will be end location. And we're gonna plug this into our beam end here. So we'll set a start location that will be randomly generated by our weather system, and an end location based on that start location. We'll have some variety in terms of angled strikes or not. And then we are going to add one more part to our emitter update, which is a spawn burst instantaneous. So in this case, the spawn count is a number of segments in whatever our ribbon is. We're gonna have 100 particles for our segmentation, which gives us a default burst of 100 particles for a second, or actually for however long we make it live. Right now it's living for, according to this, 5 seconds, but clearly it's, oh hey, yeah, it is 5 seconds. I'm not actually doing it for 5, but that's fine, because what we're going to do is change our lifetime to 1 second. All right, mass, we don't need to worry about. For our color, we will do a direct set. And in this case, I'm just gonna leave everything as is, because our emitter color is actually the temperature. We don't have a color, but I do just want to make sure that alpha is 1 there for the way I'm doing this. We are going to do a spawn beam. So this is the actual beam. We just want to make sure this is 0.00, whatever it is, to 1. Then we are going to create a beam width, which, by the way, yeah, we could have just done the beam emitter already and had half of this done, but I really like doing things from the ground up. For our beam width, we are going to do a float from curve, and we are going to add in a middle point here. Let's select the first point, and this will be a 0, 0 value, if it will let me switch over. Sorry for the squeaky chair in the background, by the way. I've been trying to ignore it as I'm doing this. For time, it's 0.5 by 1. And then again, we're gonna select all 3 nodes. So I had the middle one selected already. Hold my shift key down for my marquee select. And now all 3 selected, I'm gonna hit 1. So we get this nice little curve here. I'm gonna select the node to the left here, the point to the left, and I'm gonna push the curve up. There we go. And I'm gonna lower it just a tiny bit. I want it closer to 3. There we go. Actually, I want it at 0.8 is exactly where I wanted it. Going to do the same on the left, and I want it again near 0.8 or near 3, 0.7, 0.8, 2.8, sorry, I thought 2.8, not 0.8. For our normalized age here, we're gonna get rid of this, and we're gonna search for ribbon linked order particle version of it, not the stack context. Plug that in. For our curve, we are going to change this to a random range float. So this is how big our curve will be at this point. And we're going to set this to a minimum of 2,000 with a maximum of 4,000. Now that we could also tie into what I was talking about earlier with our width here. By the way, now that we've done this, I'm gonna break this for a moment and plug my temperature into my B value there. Control or shift save, apply, whatever. Now, it's actually good I did that, because now we need to address what I just did. We now need to address the temperature by doing dynamic material parameter. We don't care about parameters 2 and 3 currently. What we do care about at this point is the first one. And notice it's auto-filled in temperature because we have the material already plugged in. And again, I'm gonna default this to 8,000. And you know what I'm actually gonna do is I am going to create a new float for this one, and this will be called temperature. All right, I'm gonna plug that into there. And now let's go to our particle update, our particle state. We got nothing to worry about. We really don't need a collision, but what we do need, I believe, is a solved force. But I'm gonna test this by putting a jitter in. Well, apparently we don't need a solved force. I'm just so used to using that. I think I did that because I have a collision in my test version, which I didn't end up using. We're gonna set the jitter amount to 0.2 and the jitter delay to negative 0.01. All right, we're gonna just apply, save that. And now we have one more emitter to make for our lightning system. So go to FX, Niagara emitter, and this will be another empty one, just because again, I prefer working that way because I'm a weirdo. And this will be our lightning impact. Let's pop this open. Let's go down to our sprite renderer. This will be our M. Actually, I lied to you because I don't think we made the material for this yet, did we? We didn't. The answer to that is no. So let's go ahead and make that material. Wondering why I felt like this was going faster than it should have. Go to weather systems, lightning. Let's make a new material called M underscore lightning impact. All right, let's go ahead and open the lightning impact up. And our lightning impact, what we're gonna do is we are going to do another additive material. So it's surface additive. It is unlit. It is two-sided, unlit I said, with no ray tracing setting. We will want to use this with a Niagara sprite emitter. And if you want to try it, combine it with the ribbon emitter, you can, but just make sure to mark with ribbon. And we care about the opacity and the emissive color only. So what we're gonna do is we're gonna do a particle color, grab particle. We are going to multiply the RGB by one of our textures. So we're going to do a texture sample. There we are. We're going to promote this one to a parameter, and this will be our sparks texture. We're going to take the RGB off of this one and go into that multiply. And we are then going to duplicate this multiply once here and once up here. That wasn't it. I'll move it down here actually. This multiply will go into the B, and then we are going to set this value. Sorry, no, there's no second multiply here. I was looking at my prep file and I have an old test in there. Oh yeah, also put this as T spark 1, just so you can make sure that we're getting that sort of fadey sort of colory there. It's not fully set up yet, don't worry about it. Grab the alpha from the particle color, grab the alpha from the texture, multiply them together, and that goes into our opacity. And now you can see as we move around it, we get that fade. Kind of similar to our raindrop actually a little bit. Now, again, let's save this. Let's then create a material instance out of this. And let's just switch this over to tsparks06. That was the parent. I want this part. And, oh, that was not what I wanted. Sparks06, and you can see the little starburst pattern in there. In fact, I think I'm going to use this one in this tutorial. Let's go back to our emitter here, and we want our M sparks, or M lightning, sorry, I'm seeing the material name, instance. I'm going to very paranoidly double check that in my Niagara emitter. I have used the instance again, not the actual main master original material. All right, sorry about that. And now what we're going to do is we are going to leave that as is, go to our emitter state. We are going to change this to self as usual. I feel like I skipped something in our lightning, so I'm just gonna go back to the lightning for half a moment. And on the lifetime, I did change it, never mind. All right, so we'll leave that as self. We're gonna do this also as once. We will then do a spawn rate. We will have a spawn rate of 50. Hey, look, there's our stuff just kind of flickering there. Kind of cool, right? For our initialized particle, what we will do is a uniform, or random, I guess. And it will be, I really don't want this to be uniform though. I do want it to be random for each particle. Oh, that's a particle spawn, so it is random for each one. It is 0.6. I was thinking of the emitter when I said that. 1.5. We will actually have a color here, and we'll create a linear color, which will be our impact color. So I can drag that over there. For mass, we'll leave it as the default. For our sprite size, we will do a, we'll start with the uniform, which really isn't what we're going to do. Actually, Yeah, we do random uniform. Yeah, we'll do random uniform. 2 to 10 for our spark size. We are then going to add a cone location in. For our cone location, we are going to have that at 40 by 100. For our offset, we'll leave that at 0 actually. I was going to change something. That is 1, and notice that we have our cone showing up. What we're going to do though is change the velocity in our cone, so it's add velocity in cone. We will need a solves clearly. For our add velocity in cone, we're going to add a strength of 100 with a cone angle of 1000. We will set our cone axis to 0 and our Z to 10. So we are, when I get this fully set up, going into the air. Now in a moment, we'll take care of everything else. We'll do gravity, sorry, in terms of those errors. We'll add gravity under our particle update. And again, we'll leave it as is. We will then add this above our particle state. We will then do a scale color, because the color is going to change with time. And what we're going to do for this one is just turn this into a, sorry, we're going to scale the alpha. What we're going to do is take our scales color here, convert to linear color. Make vector from linear color. Take the color here, plug that into there. And for our alpha, we are going to do a float from curve. We are going to start this at 0, 1 and end at 0, 0. Or sorry, start at 0, 1 and end at 1, 0. Select both nodes. We are going to then make it a nice sort of curve there. We will do another collision. We'll add a collision event. I was thinking of the rain when I said another. And on this one, we're actually going to change the values. Our bounce is going to be 0.4, so they do get a little bit of a bounce to them. And our friction is 0.5. All right, this will be a nice little effect that we can probably take a look at separately. Now let's take care of all those errors by adding in our solve, forces, and velocity. So that error should go away now. And then we're going to, notice now, hey, what's happening is it's kind of shooting upwards. We might actually want to change this to 1 so we get let's do that at 0. We can play with the numbers later on. Then we want to scale particle by scale sprite size by speed. And so this either will be scale sprite size. Oh, that's not right. That's not scale sprite size. Scale sprite size by speed. The name in one of the versions is slightly different. It might be sprite size. I can't remember the order, but it's the same thing. It's the order of the words are slightly different. We're gonna set this to 0.1 to 0.1. Sorry, 0.1. I make the same typo a second time. And then our maxes will be 1 and 1. And then let's just make sure that we go to here. We need to change this to velocity aligned in our renderer. And our system, or our emitters, are set up. This is the longest video in this section so far, but now that we have our emitter set up, we are going to pause here, and in our next video, we will actually take care of our entire system, including having a flash. By the way, we've already done the flash, right? It's part of our actual lightning system so far. But let's go ahead and Control S, save everything, and do our usual outro. And as usual, this series has been brought to you by Patreon sponsors like Hanas, Rian, Connor, and 1Volt 10. If you've enjoyed working on your lightning emitters for part of your weather system, make sure to hit the like button down below. If you want to be here when we actually implement our lighting system and see it, lightning system, and see it in the game with the flash and all that other fun stuff, then make sure to hit the subscribe and notify icon. If you want to help this channel out a bit further, consider becoming a Patreon supporter. Patreon supporters at upper tiers get instant access to all ongoing YouTube projects, and at other tiers get access once a project is completed. As always, I look forward to seeing you in the next tutorial. That tree needs to be moved. And I hope that you have a wonderful day.